Hello, how are you?
I'm good.
Oh, good. All right, glad you could make it. I didn't send out the notification until like 5 minutes ago, so I hope people remember. So, do you have an update for this week?
Yeah, sure. I'll share my screen.
All right.
Just 1 second. I'll be back.
Okay.
Yeah. So what I basically proposed is by June 14, I would complete this. Sorry, by June 6, I would complete the setting up the Django, like the GitHub authentication in the web interface and fetching the data from the API and all that. So I'll just show you the website. Just a second. Sorry. Uh, Yeah, my screen is visible now.
It's blank. Oh, there it comes. There it is. Yeah, good.
Yeah. So actually, for the UI is very minimalistic as of now. I will improve it in this week. So right now, if you there is just the sign in button. So once you press the sign in button, it takes you to this page where you can see the sign in with GitHub button. I'll just show you. So basically, you press sign in, and then you do sign in with GitHub. So once it's loaded, it shows you this message. This it is picking up from my GitHub account, my username and my name. And if you go to this repositories page, this is just a sample table over here that I have loaded as of now. I intend that these tables are filled with the repositories of the user. So this is the API call that goes in this page, which is basically a list of all the repositories of the user. I'll just show it to much better. So yeah, this is the API call. So this is in the JSON format. This is the list of all the repositories of the user. So as you can notice, there is a variable for private. There is this variable for this repository called private, which is set to false, indicating that this is a public repository. And then there is also a variable called fork true. So this is saying that this is a fork repository. So what I was thinking is I can have three buttons over here. One which says it's your repositories, one which says it's the fork repositories, and one which says it's the private repositories. And the table will give like three buttons over here. And if you press the all button, you get a table displaying all of your repositories. You press the fork button, it will show you a table containing your fork repositories and so on. So once you have a list of all your repositories, you can just click a button here, and the values, like the data of that repositories, would be taken, and that would be sent to the agent-based model for the simulation. So as of now, this part is complete according to my proposal. This part is also partially complete. I would say it's 60 to 70% complete. And this part also, I will wrap it up in next 2 to 3 days. Apart from that, I think by in the next 2 3 days, I can probably wrap these 3 weeks in the next 3 to 4 days.
Okay.
So I'll try doing that. And yeah, that's my plan for this week.
Okay. Keep your screen up. I want to go through a couple things here.
Sure.
So
Sure.
you're going to set up a sample organization that serves as a data set. So you're going to just create an example organization and on GitHub, or is it going to be like a data table, or what do you?
I was initially thinking of creating it on GitHub. But the issue with that would be if I create an organization on GitHub, I would have to generate like it is difficult to generate synthetic data for the organization.
Right. Yeah.
I will create a repository, but it would have like only me as a contributor, and there would be no number of issues or PRs as such. So I was thinking either adding a dummy data, maybe a CSV file or a spread Excel sheet or something, or I was thinking to do something like that. Or maybe I can just take a sample existing public organization and use that for testing.
Yeah. You could just, yeah, actually, synthetic data might be the way to go. If we just kind of, even if you took like a sample organization and just kind of modified it and rename things, because you don't really want to take the data from like another org, you know, but you know, it'd be nice to have that, and then we could have like a synthetic data set. We could work from there for future work. Um, you know, where we have like some sort of table where we can see the kinds of things that we need. Maybe we need to create data for other categories, because you know I've mentioned before that you know we're interested in collecting data from multiple places, so GitHub repositories, but also other types of contributions, and that might actually allow us to give people at some point, you know, sort of a gateway to saying, okay, let's start quantifying your community outside of GitHub. You know, can you put in like, can you estimate the number of contributions or hours that people have contributed to a certain thing, like, you know, building documentation, and it's not going to be reflected in the GitHub repository, but I mean that's a possibility. I don't know. I don't want you to spend like 2 weeks on it, but just you know, if we can like, if it's like something that you just quick and dirty mock up of like some synthetic data, so that you know we have something that isn't like just taking someone else's information, but also is useful for future development.
Yeah. I'll try it this week.
Okay. Can we go back to the website or the web page or localhost tab? Yeah, so that's so
Yeah,
the
it's right now running on Windows.
yeah, so the tags are for. I kind of missed the tags part.
No, it's actually it's just a sample table that I picked up from the documentation. So I will update it accordingly when I display the repositories in the table.
Okay, so the
The
tags.
tags were just in the files.
Oh, but I mean, like, if you wanted to use tags, what's your? Do you have a vision for like how you might use tags if they were specific to the project?
Probably like when there's a GitHub repository, I'll just sample project. Yeah, basically we have these languages over here in GitHub. So maybe I can display the languages or the text tag or the tags. Or GitHub displays it here on the right side. Maybe something similar can be done.
Yeah.
The languages in which the project is developed, I can maybe put that in the tags.
Yeah, that might be useful actually. In especially in terms of like if we have like a certain pattern that you see in the simulations, it might be linked to certain using certain languages or like the predominance of one language in a repo versus like a multitude of languages. So that might be useful information. There are also tags in the repository. I don't know if it brings it up if you like, you know, like they're not like tags on the side. They're tags above. Like, yeah, you can generate like it says tags up there at the top next to branches.
Yeah.
Yeah.
It's not there on this repository, but yeah, I have seen those.
Yeah.
I'll try looking into that as well.
Okay. Yeah, I think that would be good for like metadata purposes, and I don't know, like, well, we'll see what happens if you can get it to work or whatever. But yeah, so the authentication is good. You know, last fall we kind of stopped there. Brian and his team were working on it, and they had like gotten to the authentication part, and they ran out of time, and they really couldn't figure it out. For you know, it's not easy to figure out, I guess, and so they stopped there.
Even
So
I did face a lot of errors doing that, but
yeah,
I got it figured out.
So yeah, I'm glad you're able to get it to at least to this point, and then you have the things coming up. You're developing Mesa models. You're getting I mean the GitHub API. Yeah, that's a good resource to use. I don't know. My understanding is it's a bit hard to use, but you know, that's fine. We were talking about using that for scraping data at one point, but I don't know if that's something that can be I don't know what the
In my
limitations are.
opinion, it is a bit difficult to get started with it, but once you have the initial setup done, then you can basically do anything with it you want.
Yeah, yeah,
Only the setup, I think, is what scares people, but apart from that, it's pretty easy to use.
yeah, yeah. It's but yeah, that, and then I mean, we can use that too to do some of these things. I'm not really sure what the functionality is there, so that that's up to you. That's if you find that to be useful. Yeah, and then yeah, so then the Mesa models will be good. Actually, I'll mention in a little bit. We have someone in the lab, Ankit Grover, who's been around for several years in the lab, and it was taking an interest in this project this week in the Slack. So I'll have to talk about that in a minute. But yeah, this is a nice next step, the Mesa models part. So okay, anything else?
No, that's it from me, sir.
Okay, well, thank you. That's all I have.
Thank you.
Welcome, Jesse and Rishali. Hi, how are you? Jesse has a Notion document here for people if you want to follow along, put notes in or whatever.
Feel free to add anything you want during the meetings of relevance there, because they're kind of our documents for these. These videos are sort of it's a video record, but it does help, and it's good practice to take notes of the actual meetings too. I think Rochelle has updates to give. I have some things to say too, but they're much more like broader than the specific work here. So I'll defer to Rochelle first.
Okay, yeah, Rishali, why don't you go ahead?
Hi, today I just sent you the Morris Watermaid's assets I made
Yeah.
for our. So, do you like it? Any feedback regarding this, or shall I change it? Or it looks good? Asking.
Oh, do I think I have it up here. Let's see if I can pull it up. Or I have it here. And this is the Morris Water Maze. Rishali made this. She sent it last night, so I was looking at it. Yeah, this looks nice. So could you describe the parts here?
We are just going to focus on our experiment. Now, it's just for setup. We are not going to use the rest of the things. Just we get feel of we are in lab and doing experiment in VR stuff. That's why I add those things.
Yeah. This is the pool here.
Yeah. Pull that mouse. Right.
Yeah.
And we will spin in Unity. I will do that in this way. Making simulation. I'm thinking about doing it in with ML agents. So he will, like the rat has its own neural network brain kind of thing, and he will follow and do it its own instead of we doing agent based instead of doing agent based model. That's what I think of doing most probably. If you have anything, please say you can take.
So this model is good, but remember I told you about the walls. So the wall, I guess the arena has walls here, right? Along the edge. So I mean, maybe these can be higher. And yeah. Yeah.
If I do ML model instead of AVM, then that will be okay.
Yeah, I think so. I just kind of threw out an ABM model because we're kind of doing that. But we're interested in a lot of different types of models. Obviously, you could do a reinforcement learning model, which would be the closest to a rat's behavior, or at least what they tested in the pool. But you can do ML. You can use a variety of techniques to simulate the rat's behavior. That would be fine. I don't know what fits. Yeah, I don't know what would be the best way to do it. I mean, what would be the easiest way to do it? I don't want to make it like impossible to implement, especially in Blender. I think there's some nice, artificial intelligence modules. It could be neural networks. It could be like something similar to that. Um, I don't, they have like procedural modeling stuff in there, so I don't really know what you want to use, but yeah, that would be fine.
Okay. Uh, I have this. Okay, let me share my screen.
Okay.
Uh, this is the set. Yeah, this is the set anatomy, which I found, where we will have all the assets related to anatomy. So, okay. This kind of models we get. Uh, this is free, open source project. So I'm thinking about doing and like using these models. We have others also, like skeletal, muscular. I didn't check it badly, but yeah, we have lots of things here, and each things are like not responding. Yeah, it will take time. This is huge. This file is huge. This model.
Yeah. So you could plug in things to that, like you have the pool, but then you could take that out and put in other things.
Yes. So I don't have to make that anatomy stuff, which will be complicated. Like it took me weeks only to make that lab more sort of maze experimenting. So I don't know how to do it.
Yeah, there's always a learning curve in some of these scenes, like composing them and getting them to work together. So yeah, that's good though. I like that you have a model already. It looks pretty good. I mean, you make some changes and then you can use that as kind of a base.
Yes.
And switch things out. There are a lot of assets that are open source.
Yeah.
So yeah, there's also like the stuff with there are all sorts of stock like anatomy stuff, but there are other types of they've actually have a lot of biological modeling kits where you have like different 3D objects, so you can plug those in, as long as you have the rights to them. We just want to use open source stuff for this project, and you can plug them into whatever, and so you don't have to make everything from scratch, and that's good because you can spend time putting pieces together. So
yes, and I have to model open worm, like the worm we have that Glide model, and rest we have for anatomy stuff.
Yeah, we have the OpenWorm. Actually, the OpenWorm model is a Blender file. I should send you the link to the latest version of that, because there's a Blender file on GitHub that actually was worked on last summer by an intern in the OpenWorm Foundation, and he was working on updating it for the latest versions of Blender. So that should be, you should be able to plug that into Blender, and it just comes up as the model. So all the parts are there, and I guess in that case you can play with it you could probably maybe make it into like a first person point of view, or there are ways, I don't know what you want to do with it, but you'd have the whole model there in Blender, and it's all annotated. So
Can we do simulation for open worm? So I thought that it's like the how that worm developed, the whole process kind of thing, the simulation evolution of the worm. I have watched the video where they put little creatures and they evolve within time. So that looks pretty interesting. So I thought that we can do it with worm. How it works.
yeah, it would be pretty good, I think. So what I'm talking about here, well, actually, we can go through. I know we showed this, I think, before in the community period, but or 1 minute's on it. It's a browser, not Blender. Blender on the brain here. Okay, this should be the link. So let me share my screen. Okay. So this is Blender, where this is in Blender, and it's being put up on the web, so it's being rendered to the web. And of course, you have these different layers. You can zoom in on it. This is the whole worm. You have these different layers, so you can subtract away this is the outside called the cuticle. You can subtract away to look at the muscle pads here, muscle fibers, and then you can subtract away those, and you can look at the inside. You can look at some of the internal organs. You can look at the nervous system, the nerves, and the neurons. This is something when you look under a microscope, it actually looks kind of like maybe like this. They're sort of sometimes they're semi-transparent, sometimes they have a thickened cuticle, so they shed their cuticle over several times over their lifespan. But you get like that's the kind of microscopy view, and this just kind of gives you like all different potential views. Like this is just minimizing it to like a few nerves and neurons. So there are all sorts of things you can do with this. Like, you can look at different perspectives. You can rotate it like this. You can, take away different pieces of, cuticle or tissue, or, strip it down to like just a minimal connectome or something like that. This is like the nerve ring. And, so there are very few parts. So there are different things you can do. And then another thing you can do is, you can put like this as a sort of a external perspective on it. So, can we get this, can we zoom in? We can zoom in. But can we get inside of the worm or inside of this architecture, I guess, is the best way to put it. Inside the anatomy to look inside of it. Get the viewpoint right about here. And you can look at like the neighboring neurons and the neighboring nerves, and then you can look at like different tissues. Look, obviously you'll be looking up at the cuticle if you're inside of it, but like you'd be inside of the worm. You have this view. It's pretty occluded, but you can open it up by doing this. And it's really virtual microscopy because, to look at the worm, this is just built from a lot of microscopy data. And microscopy, these different techniques to like, see inside of the anatomy. So they might use clearing techniques. They might use different types of light scatter. They might use different types of like electron microscopy versus light focused arrays, things like that. Simple microscopy with a simple light source. Fluorescence microscopy where you stain some tissues and you put some UV light on it and things glow in the dark. And you can do all those things. In the virtual model, you have a lot of that information kind of in the model. So this represents a lot of that information. And so what we want to be able to do is, get inside of it or explore different orientations to really kind of get at like what this looks like. the geometry of it, sort of the, looking at things, from different perspectives, because under a microscope, it looks something like this. You'd get a stack of views like this, and all you could do is go through the slices. And people have done this with like visualizations where they go through the microscopy slices, but the focal plane is different, so it's hard to really get a good unified perspective there. So that's what we have in terms of the browser, and that whole thing is available as a Blender file. So you can actually open it up in Blender and explore it and put different viewpoints in and things like that. So that's the OpenWorm browser, and I think you should probably try it at least. See what you can do. Right. Okay. Yeah. Yes. All right. Yeah, that's good. Thank you, Vishali, for the update. Yeah, it was nice to see that you send me so you can send me the updates like, in Slack. And I hope that, you can push it to GitHub. Okay. Jesse's going to be right back. Please, keep your GitHub resources updated, because, one of the things about working on open source is having it open, but also we don't want to lose any work if there like a computer crash or something. We want to keep everything synchronized. We don't want people getting confused over what file is the most current. I mean, this is workflow issues that I feel compelled to point out. That's why we have, we use GitHub a lot for, pushing things. And so, you can adopt your own style with respect to GitHub, but basically just commit those, like the Blender file should be committed to GitHub. The Django stuff should be committed to GitHub, and then we can have different versions of it. We can update the version. We can, if we don't use something, we'll still have it in the repo. And then at the end of the project, or at the end of the summer, you're going to turn in like a repository basically to Google. You'll have like a repository with a README. In the README, you'll really kind of tell what every file is, what it does, and then you'll submit a single link to Google, and they'll evaluate the project. So I just want to keep that in mind as you're working on this, so that we have at the end of the summer, you don't have a mad rush to get everything put together.
So made a repository for the work on that.
What was
I
that?
am making commits.
Okay.
Am I audible?
Yes.
Yeah. I was saying that I have already made a repository for the project I'm working on. And as and when I add any new feature or anything, I am making commits. So I'll share the repository link and access in the Slack channel after the meeting.
Okay. Yeah. That's good. And we can do, ultimately I want to be able to push it, or I want to be able to clone it to orthogonal lab. But you can adopt whatever work style you want. I've had people do their own in their own GitHub account. I've had them do it in the lab GitHub account. It's not, as long as it's on GitHub, and just so you have it. And of course, with GitHub, you have version control. You have, you can keep all the documentation in place, and it gets backed up, so you don't lose it. Unless, well, I was going to say, unless you lose your password for GitHub and you get locked out of your account. Now, I'm not saying that's from personal experience. I'm saying that like that can happen. No. Okay. Yeah. So yeah, thank you, Vishali. Yeah, that's good. Now, so Jesse had to step away for a minute. So I know he wanted to give an update, but we'll do that after. I'll do a feature here, and then we'll do Jesse's update. So yeah, thank you for the updates. Let's keep going. We're still, I think we're in the heat of the coding period, so it looks like we're doing some good work. Okay. Let me share my screen again. And today I want to talk about command line interfaces and graphical user interfaces. And so we talked about how you might work in, or how you want to deliver your projects. Some people prefer command line, some people prefer a graphical user interface. That's true of GitHub. You can use GitHub as a CLI. You can use it as a GUI or a GUI. You can use, obviously like things like Linux in the same way. And then in the same way, you can build a program. You can either call it from the command line, which is like where you use a command, you open up a terminal, use a command, you bring it up and run it, or you can create an executable with a GUI that allows you to interact with things. Now, for the web stuff, for the web backend, that's going to be like its own thing, and it's going to be called up probably in a GUI. The same thing for VR. You're going to have a GUI because you have 3D objects that are going to create a scene, and that's now a lot of our previous students I've required them sort of to create a graphical user interface for their projects. And this is like something that you do in the last week or so. So once you get all the code together, you package it up into an executable, but you create a simple GUI to show, like, so someone can interact with the program, they can set parameters, they can look at what's going on, and I think that's useful for a number of reasons. But there is this debate in computing about which is better, the CLI shell or the GUI. This is a blog post here from James Ferguson. This is CLI versus GUI. And this was from last year. This is in the domain of bioinformatics. So in the field of bioinformatics, there's a lot of data in especially like next-gen sequencing, but in a lot of areas of like genomic biology in particular, but in microscopy data as well in biology. And so people have spent time creating bioinformatic tools that allow you to take all this data and analyze it. And then, those tools are, of course, very useful, but sometimes they're useful to biologists. And biologists don't have the same culture as computer scientists when it comes to this sort of thing. So computer scientists are usually used to command line interfaces. They know how to use them. A lot of biologists may be a little bit shy or even afraid of command line interfaces, although that's less true now. It used to be very true. It's like intimidating to have to put in a command that you don't really know, a program you can't really see what's the operations. So that's why we have graphical user interfaces in the first place. But you have to think about that when you have people using your program or your tool who may not be used to working with a command line interface. And a lot of people aren't, especially nowadays, because we are so used to graphical user interfaces. Our web browsers are graphical user interfaces. Like I just showed Blender, that's a graphical user interface. So those are very common. Command line interfaces, of course, are very useful for issuing specific commands, interacting with the program at a deeper level, but oftentimes people are intimidated by them. So that's where this is coming from. So this blog post explores this in the domain of bioinformatics. So bioinformatics is where people are creating tools to analyze biological data. And the audience for that are usually computer scientists, but also biologists. So biologists are going to have different needs as computer scientists. And so these tools actually are very useful because you can, do a lot of really cool analyses. You can access the data in ways you couldn't before. But, you have to create the right sort of interface for the tool to make it useful. So this is the thing, this is the sort of the takeaway of this article. Almost all bioinformatic tools need a CLI, which means that they all need to have, almost all tools really need to have that level of playing with the program at a very deep level, issuing specific commands and getting results out, working with settings, whereas only some bioinformatic tools need a GUI or a GUI. So, that what that means is that almost all bioinformatic tools are used by, computer scientists or people who want to really kind of finesse with the settings. You know, it may be that you want to run it for a very deep analysis and you want to really kind of get, you know, you may need to like get different data sets and align them and do things like that. But only some bioinformatic tools need a GUI, and those are the kind of tools that are used by a more general audience. So a lot is riding on the use of need. What I mean is the tool would not be usable in its most basic state without it. So a tool that requires a lot of human intervention and interaction, a GUI might very well be needed to be functional. Whereas a CLI can add a different way of doing it. The GUI is the tool. I think of tools like IGV for viewing read alignment. So this is the tool that he's referring to. This is a read alignment. This is where you have different data sets pulled in, and you're aligning them based on their sequence. So you're finding where the sequence is. So they don't come out all aligned. You have to do that with the program. So you have to figure out, where the usually it's like a stretch of DNA. You have to figure out where they're similar, and so they're usually aligned when they're similar, and where they have gaps. And you have to kind of put that onto a chromosome and map that to a chromosome. So this is what this is referring to, these base pair numbers. And usually you can get this information from like some sort of reference sequence. So you're aligning a lot of different things here. Now this GUI is actually quite essential for what you want to do. You want to build this basically this model of analyzing data, and you want to see where your alignments are. You don't want to just rely on kind of making guesses or kind of reading a bunch of letters and strings that are kind of wrapped around a bunch of text in a text window. So this is a very easy way to do it. And I actually remember when they used to do a lot of like alignments in like a CLI, and it was not fun. I've seen it done, like it wasn't that long ago. But you can do this in a CLI. It's horrific. It's very hard. This is a lot easier to do, especially when you have really big data like this. And so this is, this has all the accoutrement of a GUI with different labels and so you can, a user can actually use it. But, with a CLI, you need to have like, you can make different changes. You can get a little bit deeper into the settings, into the data. You can play with it more. But the GUI is essential for like really doing the work and presenting things. So a tool like Minimap 2, which they don't show here, needs a CLI but does not need a GUI. So a tool like Minimap is where you make those alignments that give you this output. So getting to this output, you don't need a GUI, but to work with the output in this way in a framework, you really need a GUI. So that's why they're making this kind of distinction. This brings me to why someone might want a GUI or CLI. There are many people in the bioinformatics space: tool builders, tool users, scripters, pipeliners, and a variety of wet lab, dry lab use and exploration. A wet lab is where they do biological experiments, and a dry lab is where they usually do computational stuff. Many people sit in multiple areas as well. In some cases, a point-and-click GUI is going to be the best for some users, while for others, a CLI is a must, and a GUI-only version of a tool is going to make it impossible to automate or implement in a pipeline. So another reason we want to use a CLI is because we can manipulate the program to make it work in a pipeline to modify its use cases. So this is something that, when you're, maybe not in the projects you're doing, but when you think farther out, when you're working in different areas, you want to make this distinction. You want to know when you need to use the command line, when do you need to use a graphical user interface. And sometimes you need to implement both. Sometimes one is better than the other, depending on what you're doing. So that's that article. There's another article I wanted to show. I don't think this is going to work. Okay, didn't upload. And then this shows the history of the graphical user interface. So, our graphical user interface actually started in the 1960s. And Douglas Engelbart, he worked in SRI International in Menlo Park. he worked on something called the Augmentation of Human Intellect project. And this was something that he worked on, and this idea of being able to do things like video conferencing or working with things on a screen, working with icons. So in computers they used to just have lines of code, or even like assembly language. You wanted to get for general audiences to use the thing, you needed to get above that and have a layer where you could have like representations of objects, icons, things like that. They didn't really talk about icons yet, but this is something you needed to do to really manipulate the things underlying it. So to manipulate like spatial positions or objects relative to one another, you needed to do this in a way that was virtual but also appealing to people who intuitive to what they were used to. So much of the early research is based on how young children learn. So the design was based on the childlike characteristics of eye-hand coordination rather than the use of command languages. User-defined macro procedures or automated transformation of data is later used by adult professionals. So this was then Engelbart moved to Xerox PARC, and where he actually influenced the people at Xerox PARC. Which was going on. They had work going on in the early 70s on this. So they picked up what Engelbart had proposed. They started working on this. They developed the Alto personal computer. This is where they started to develop some of the icons and other types of virtual objects that we use. And there's this desktop metaphor that emerged because people were used to using desks, writing on paper, having like file bins where they like an inbox and an outbox. I mean, these are all things we know from like email and from your desktop environment. That's where that comes from, is from from the office environment of the middle 20th century. So they use that as a metaphor, and they kind of designed around that. They were able to kind of develop this at PARC. It was an internal thing to Xerox, the company that ran the PARC Institute or the lab. But it was also an influence on personal computers. And so the Apple Lisa was the first computer to really feature this sort of GUI, this sort of formal GUI. And I guess the legend is that Steve Jobs spent some time at Xerox PARC, and he brought it right to Apple, and he said, we're going to build this interface. And of course, the Apple Lisa was a failure, but then later got incorporated into Macintosh computers and then into Windows computers, and so on and so forth. So the modern WIMP GUI was first developed at Xerox PARC by Alan Kay and Dan Ingalls and David Smith, Clarence Ellis, Larry Tesler, and a number of other researchers. They had this prototype called the Smalltalk programming environment. So they actually developed a programming environment based on Windows icons and menus. So when we talk about the command line interface, that's a choice at a certain level of abstraction. You're writing code into a window, you're getting an answer in code or in commands. You can also do programming in a GUI, actually, as it turns out. And this is the Smalltalk environment was the first use of this. And we actually do that now. I mean, with Blender, you're doing this. Basically, you're building models. These models are like code. You're moving them around. You're putting them together into pieces. You're composing scenes. That's all code. You're just doing it with graphics instead of with code or with a formal window where you're typing in commands. So we're doing that today. It's just that it's not apparent to people always. So they worked on this, and this is when it was first being developed. So you have to remember that they're kind of trying to solve a problem. They're trying to bring computers to a more general audience, and these are the kinds of problems they're trying to solve with it. And so there's the Quantel Paintbox, which was from 1981. That was a very early graphical workstation where this was like a big feature at the time that wasn't like incorporated into everything we do. So then, of course, the Apple Lisa, the Apple IIgs, they all use this sort of thing, and then you get into the sort of the metaphors of this graphical environment. And so when we use something like Blender, there are a lot of things that we can, there are a lot of metaphors we're using here with respect to space, because we're actually not in a real space. We're just kind of moving around, and everything's virtual, but we're using real world metaphors to sort of guide that. And so, this is important to think about when we think about like designing software. I don't want to get too far down the rabbit hole here, but like, when is a graphical representation appropriate? When is a command line representation appropriate? And what can we do with our virtual representations to make them more like maybe user friendly, or can we even use those, to sort of encourage no code development, which is where people don't use code. They just kind of, run, like they just move things around and they can build expressions and things like that. All right. So that's all for that. Now Jesse's back, it looks like. So yeah, if there's time, I'll briefly preview the GSoC site, but it's not urgent.
Yeah.
Roshali and Raj. So go ahead, Jesse.
Yeah, I was back a little bit earlier. I started a bunch of calls come up. Yeah, if Rochelle or Raj, you wanna, I know it's there, but it'd be a little bit easier if you read it out like in Slack or here. I will put it into this setup, but I'll share my screen quickly. It's cool. It's actually really cool to see everything in like one space, because I've never really seen it all before. Actually, I'm gonna switch this out. Hold on a second. Where is the other one? Okay, yeah, here we go. Okay, hold on. All right, sorry. So as you may, this whole thing, as you may recall, like our current Google Summer of Code stuff is a little all over the place. Like I came in a long time ago on with Stefan and Gong Z, and I think Ankit Gupta was also in that cohort from 2019, which feels like, wow, a long time ago in some ways. I remember I was graduating at that time, and there was Sam Felder, and this is just the orthogonal lab side of things. And there's also this open source ethics more recently with Hussein, Brian, and Himanshu. And then on the DevaWorm side of things, there's kind of a little bit more robust, unified thing here with all the different presentations and pictures and stuff like that. I'm not sure I'm going to do pictures or not yet, but what I am working on is updating this bigger website, and go back to here. This is all in draft state right now.
Yeah.
But I'm going to basically get the logos for DevaWorm and OpenWorm and the lab and break it down a bit more. So I think you have eight or nine students from RL, and then a whole bunch from DevaWorm. I'd probably close to like over 20 total. I think that's a really impressive number. Like you've brought a lot of people through the Google Summer of Code.
Yeah, we've had a lot of people so far. I mean, it's been like I think going on 7 years maybe. So we've been doing it a long time.
Yeah, I was actually going to ask. I have data going back to this is all like the format here is a little crazy because I've been playing with different ways to lay out stuff on the site. So don't mind that too much. But like I see stuff going back to like 2017, and I don't know if there's anything older than that that isn't on here. But that's like the earliest one I can see.
That was the first year, I think, for DevaWorm.
Yeah, and that was like sort of a DevaWorm, and there's been names I recognize but forgot were here, like Arnab.
Oh yeah, he moved on to INCF. Actually, it's interesting. He was an intern here in 20 or in DevaWorm in 2018, and then he ended up working for INCF as like a liaison for their GSoC project. So
Yeah,
you
yeah,
have
yeah.
this, helping
He's
people.
in the emails. Doesn't he write some of the emails for
Yeah,
INCF?
yeah, he does.
Okay, that's like, yeah, I know him. Okay, cool. I just put that together right now. I'm like, wait a second. I've only theoretically know of him in the INCF. I've gotten messages from him in the INCF. I think Vinay's still around in some form or another. I hear his name come now and then. Mayak, obviously, and like I know a lot of like. I'm less familiar with the recent batch, but these guys I know. They kind of came in around the same time I did,
Yeah.
and I think we could do something deal too. But suffice to say, combining this and these things in the lab, we're kind of getting to a big long list of everybody that's done this stuff, which is really cool to see. Um, I think it's actually, I feel putting this together in a coherent space has been, and I've just like copied and pasted stuff so far. The formatting will improve when this actually comes out. But seeing all this is really impressive in the sense of like, wow, we've really had a lot of really good stuff come through here. So a lot of grants and funding and like a very strong track record. Thanks to Bradley for mentoring all these things that were the different groups. So this number was 2017's right. I originally did this page only for orthogonal lab, but then I said late last night, hey Brad, like, do you want me to just include the DevaWorm and just put everybody together, and like have the whole thing on one page, which we never had, I don't think. And so I'm starting to do that here with DevaWorm, and then obviously the INCF and also the OpenWorm Foundation. I'm kind of going to flesh that a bit more. So that's cool. And then
I think it's worth making a note that like they're different. See, there are different levels of sponsorship. Like there's Google, and then the INCF is the organization, and then we do have like OpenWorm versus the SLAT. That's sort of technically the group that's gets like this number of slots for students. So yeah, I mean it's worth saying like this is DevaWorm, OpenWorm.
Yeah,
this is Orel. Just to make sure that we know.
I've been breaking it down in different ways. In terms of like, I think what I'm going to do is like list. That's kind of what this area is going to be, where I'm specify things. I kind of actually threw this chat GTP somewhat assisted on this layout of things for this one. But just to kind of what is Google Summer Code, but then I also want to say, well, what we do at Orthogonal Lab and DevaWorm, sponsored by the other two organizations, like we add a little bit more to it. Like we specifically talk about like open source stuff this week. We have sort of like some mentoring, Joe Pro-ish kind of a professional development component in some of these too. And there's a really nice history here. And I'm thinking originally I started all this out as like just a compilation. And it's like there's actually a little bit of a story to tell here to accurately record the history of everything. So it's actually been really exciting to work on this, even in like a lab management sense. And we're just getting the 2003 class up here with their stuff. But that's why I was saying, hey, like Tigrashali and Raj, like I've seen your applications and I can find them up, so you don't have to do it. But if it will much expedite things if you could write like, what is your university? Because I'm kind of steering towards name, university. Also, like I'm thinking about how to identify like both the sub organization, the sponsoring organization, and the thing, the title, and then links. But also, I kind of want to collect the like the Neurostar's proposal numbers and like say, oh yeah, we've had a number of these things accepted. Like kind of saying we've had a number, like we've had, I don't know, 15 like what I forget how do we call what we as the organization write up to submit to ISCF.
It's pretty informal. It's just the project like proposal, and they just give it a number so that they can distinguish. But I would just I would basically, all of them are INCF, so you don't need to put INCF in there. You just put ORL or Devo or Open Room. Those would be the two identifiers.
Okay, so
and then,
even it's through even the warm stuff is through INCF too.
yes,
To make
yes.
that. Okay, cool. All right, good.
I have sent out my details on Slack. Name, university, interview.
Okay, great. Thanks. And I'll get that up here shortly. And it's cool to see the links too. Like this is just how it's copied from the other website, but I'm gonna more formalize this a little bit. Like this will eventually look more like this.
Yeah.
And take this away and so on and so forth. But point being, it's a very nice lineage to be a part of, and something that has been kind of a bit humbling in realizing, wow, like this is actually like a really solid history of 7 years of work here, and there's a lot of all these GitHub repos and projects, and I'm even considering basically doing like I'm a little open to how to collect some of the resources, because we had this discussion group. We have also the actual paper that's come from this one and other things too, and like having a section that says like the outputs and the total number of like not grants but like successful people that have gotten the funding fully through Google, and differentiating that also from people who joined. Like I joined the cohort. I was in a Google Summer of Code. My project wasn't selected that year. There's only one person that was selected in the whole thing.
Right.
But like
that still is. I think it's a really cool thing to show that Orthogonal Lab or Deworm is affording those opportunities alongside it too. So like all of those numbers are actually a big deal to think about, and how to like actually how do you show up and display them, and I think having like a number section up here eventually. But anyway, that's kind of I've just started this yesterday, and it kind of was just, not the most pressing of things, but it's really cool to see it. So
that's excellent. Yeah. Please let me look it over before I'll go over and make sure all the data is correct, because I have
there's a lot of things I wanted to ask about, like some of the other like links or things here, how to word some stuff, like, and especially in the older ones where I wasn't around at all. So
if you can send me a draft, I can go through it.
Yeah, I will definitely do that.
And there's a data analysis here. I mean, like to say like how many have we done? How many people have we mentored, and like what is the because I mean then they're also like the products of that. So we have a lot of products.
Yeah, there's been a lot of interesting outputs from this, and also like you can kind of say the whole like the sustainability auditing tool project as a whole was really initiated by Google Summer of Code, and your work and Brian works through last year, up and through the summer, up and through the fall, up and through it becoming a course. It became a keystone course, or a component to someone's senior keystone or capstone, I should say, at UAlbany. So it's a really fun history. But yeah, I got to actually get onto another call, so I'm gonna take it out.
Thank you for attending. So one last thing before we go. Hello, Andy. I mentioned that I talked to Ankit Grover in the chat, so he's going to come to the meeting tomorrow. So this is more for tomorrow.
Yeah, hopefully. I kind of tried to nudge him into that.
But I wanted to show this.
Join and talk to us about this cool stuff.
Yeah, I wanted to share this real quick. So this is he had mentioned in the Slack a couple things. He had a couple comments on the open source sustainability. So he watched the video and he was like, I know he had read the preprint and he wasn't quite clear on what was going on, and then he watched the video and it made a lot more sense. And so he had seen earlier versions of this with respect to the project. I like the agent-based approaches, POMDP with active inference, Marl, TD, Q-learning. It's all reinforcement learning stuff. So he's making some suggestions about the Markov blanket and the definition. And then what is the maximum expected or discounted reward of the action value function associated with learning behaviors compared to its current behavior. I think that's with reinforcement learning. And then he says he wishes this was all implemented in Python rather than NetLogo. So this is where we're talking about these models in Mesa. So Mesa is the one where you implement it in Python. So I had mentioned that Raj was working on that this summer. And then he was interested in a metric where we could compare the models statistically. So, I mean, this is stuff we'll talk about tomorrow in a little bit more detail. I mean, some of these things are planned, some of these aren't. So, just as a heads up on that. Yeah. All right. Thank you for joining. Anything else before we go? Okay. Well, I'll talk to you later. See you tomorrow. Thank you.